Hello engineers. Now in this short video I'll tell you or I'll show you how to calculate the load current or circuit current. Sometimes it is also known as branch current. So how to calculate the load current for any feeder within a second without doing any long or complex calculations. So what does it mean, load calculation, and why we calculate load current for any feeder or for any circuit. Let's suppose this is the simple a single line diagram of a power system. Just for an example or just for explanation, I am taking this example. So let's suppose this is your point of supply from where you are being supplying this is your point of supply from where you are getting supply. Okay, let's suppose this is your power system, this is your substation, and this is your load, building load, which is about 3 to 4 kilometers away from your building. This load which is installed or which is being used in any building, so that building, let's suppose it is located at 3 kilometer away from this substation. So from this substation to this load, you have to provide a system, you have to design a system, you have to provide a path from which you will getting supply. So we are getting supply by this feeder, and this feeder is connected to directly the primary of the transformer, and this transformer is used to step down the voltage of power system, which is at 11 kV up to the utilization level, which is simply it may be for 0.415 kV. Okay, because this is the volt utilization level of the voltage, or sometimes simply you can write it as 415 volts at the secondary side of the transformer. And the supply first, the total energy or total demand power of your building will be supplied to one main panel of your building, which is known as the main distribution panel. So all the demand power of your building will be collected at one point at known as main distribution panel. Then further, this main distribution panel distribute the electrical energy as per the requirement. It will distribute the energy by this feeder 1, feeder 2, feeder 3, and further this feeder is distributing electrical energy to different loads. Like this feeder 1 is supplying energy to this distribution board, and this from this distribution board, electrical power is distributed into these two feeders to supply or to provide electrical power to these different loads, which one load is consuming 15 kVA of power, and this load is consuming 20 kilowatt 20 kVA of power. Okay, similarly this feeder 2 is supplying electrical energy to this load, which is consuming for 30 kilowatt of power from this main distribution board. Similarly, this feeder is supplying electrical energy to this distribution board or distribution panel. Further, this distribution panel is distributing electrical energy into these different two loads. One load is consuming 12 kilowatt of power, and it is consuming 10 kilowatt of power. So these are the different feeders which are supplying electric energy to their respective loads. So what is the meaning of a load current or circuit current? So the current, as this feeder is supplying energy or supplying power from this main distribution panel to this distribution panel, so it will get the supply from here, and will give the supply at this point. So from this, there will be one circuit, or you can say one branch, or somewhere simply you can say feeder. So in this feeder there will be two basic component. One is a cable and one is circuit breaker. So the size of this cable and circuit breaker will be decided or will be selected based on your load current, the load current or circuit current. Okay, so the current that will flow through this cable or through this circuit breaker, that will be your load current. Under normal condition I am talking about load current, or you can also call it as a circuit current or branch current. So the current that will be flow through this cable, that will be your load current. So it is very important to calculate the load current for every feeder: feeder 1, feeder 2, feeder 2, feeder 3, 4, 5, 6, 7. So for all these feeder, we'll calculate the load current in a second, without doing any long calculation. Okay, so that's why to select the cable size and to select the circuit breaker size, we are going to calculate our load current. So first, we are assuming some points. So these are the some assumptions that we are making here in this calculation. So first, system nominal voltage I am assuming as 415 volts, between line to line. Between line to line voltage, it is 415 volts, and the frequency of the power system is 50 hertz, and the power factor I am taking zero point 0.8 lagging, and the altitude of my installation is less than 1000 meters from sea level, because above 1000 meters, if I am installing my system above 1000 meters, so there will be the current carrying capacity of the cable and other equipment will also be affected. So that's why I am taking this altitude level here. So these are the four assumptions that you have to make, or in I am just taking examples, that why I am assuming. Otherwise these values will not be as assumption for in your case, if you are doing for real time examples. So to calculate load current, we have two types of power. One is apparent power, which is apparent power, and one is active or real power, or true power, you can say. It is denoted by capital S, it is denoted by capital P. So in this case, this power is represented by kVA, or this power is represented by, or shown by kilowatt. Okay, so these two powers we have. So in this power system, or in this single line diagram, you can say we have only two types of power. This is apparent power and this is active power. So to calculate the load current, we'll use different formulas with respect to these two power. So first case is, if I am going to calculate current value or load current by apparent power, apparent power. So in that case, what will happen? So load current or circuit current will be directly equals to 1.4 into the apparent power. Just I'm taking example, don't worry. And the value of this current will be in amperes. Second, we have, and this is active power. If I have active power, so it will be capital P. So to calculate the active power, I will use another for I will use, so in this case I will use load current equals to 1.75 into P. Okay, so we'll use these two equations for to calculate our load current. For this for apparent power and this is for active power. Now in this case, now I am taking some examples. Now let's see here this feeder 4. Let for feeder 4, I am going to calculate load current for this feeder, means how much current will flow uh, through this feeder, how much current will flow. And first you should know about the total apparent power, that is the apparent power of this load, or the power that is consumed by this load. Let's suppose here we have apparent power is 15 kVA. So in that case, how to calculate the load current? It will be equals to, I load will be equals to directly just 1.4 into S. So in this case, IL is equals to 1.4 into 15. You will get 21 amperes of current. 21 amperes of current that will flow through this feeder. That will be your 21 amperes of current in this case. Similarly for feeder 5, if I'm talking with respect to my feeder 5, so for feeder 5 it will be equals to IL is equals to 1.4 into what is the power of this feeder. What is the load for this feeder? It is 20 kVA, 20 kVA. So it is equals to 28 amperes of the current. So in this case, the load current is that will flow through this feeder is 28 amperes. And what about this feeder? For feeder 1, so in this feeder you can see that this is the total load that is connected to this feeder. So this feeder the load current for this feeder will be equals to F1 is equals to IL is equals to 1.4 into 3.35 kVA. So just multiply this and you'll get the value as 49 amperes. 49 amperes of current. So this is the total current that will flow through this feeder. So this is with respect to your apparent power. But what about this kilowatt? So to calculate the kilowatt, to calculate the load current from by apparent active power, so IL will be equals to 1.75 into active power, which is P. So for feeder 2, I am taking for feeder 2 IL will be equals to this is feeder 2 F2, which is 1.75 into how much load is connected to this feeder 2, it is 30. So it will be 30 kilowatt. So to calculate the value 1.75 into 30, which will be equals to 52.5 amperes. So this is the current value that will flow under normal condition through this feeder, which is equals to 52.5 amperes. Similarly for this feeder 3, and similarly for feeder 6 IL will be equals to 1.75 into what is the load connected, how much load is connected to this feeder, it is 12. So it is 12 kilowatt. So just to multiply this value by 12, you will get the value as 21 amperes. 21 amperes. So this the load current of this feeder is, or branch current or circuit current of this feeder is 21 amperes. Similarly for feeder 7, you can calculate it is about 17.5 amperes. And the total current that will be flow through this feeder, it will be the summation of these two. And if you want to calculate, you just calculate by using this shortcut formula, and this is a 1.75 into 22, you will get so 38.5 amperes of current that can flow, or that will flow under normal condition by this feeder, which is 38.5 amperes. So this is the way how to calculate the load current for any power system. And this is just an overview how to calculate the load current. And this is the shortcut method, or this is not a rule of thumb, it is not any rule of thumb, it is just shortcut. I have derived this equation from our standard or fundamental equation. So it is very important to calculate the load current for any feeder. So if you want to learn about more in detail about the electrical designing, just connect with me at